So every project we take on is gonna have parameters. It's gonna have constraints, whether that's budget, whether that's location, whether it's the house we're working within. And we're happy to work within any one of those. But when we're working on any of those, what we wanna be able to do is find what are the levers that we can pull on for maximum impact, right? Certain levers you're gonna pull a lot to get a little out of it, right? The juice is hardly worth the squeeze. And some, you pull just a little bit and you're gonna get a ton of impact. You're gonna get a very high yield. Well, in order to find out what levers we should be pulling on rather than just stabbing in the dark, we start with data. We start with testing. So that's why on a house like this, we haven't even started designing yet. We're here doing a blower door test to get a benchmark. Let's understand, how leaky is this thing? Where is it leaking? And what are those levers? Try to steer us towards those levers that we can pull for maximum impact.
I'm actually going to go ahead and go with wide open on this, just because I need the most amount of airflow coming in for this particular application. But I mean, I think you've seen these done before. Have you done them? Have you worked
Once.
Yeah.
I've never worked on myself.
Yeah. So the A, B, and C are just, this is going to concentrate the airflow across the meter, the pressure meter that's inside. So, all right, very good. So we're going to try to pressurize to 50 pascals.
That ought to be fun.
Well, we might get there. No, I don't think we will. It's the fastest cancel out. Sorry. So 9,060, you know, for a 2,000 square foot house, it's almost open. Yeah, it's a lot. So what I think would be cool is if we kind of go around and just, let me get it up to a decent pressure, and then let's take a look and see
what's grabbing.
Let's grab some TP.
Yeah, I also brought a smoke pan if you want it.
If you want to do that, that'd be fun.
Just sucking right out.
Yeah, and you can actually see it's getting sucked through the cable. There's a pulley in here, and you can see it actually sucks it right through the pocket where that cord goes back into the counterweight cavity.
So it literally just holds it there.
That's wild.
And here's an external one doing it too.
I would have expected that one. I would not have expected that one.
This is an education point. I can tell you walls that had, I would say, 50% of the issue.
Why is that?
It's communicating with the attic.
Oh, and it's going through the plates.
It's going through the top and bottom plates. There's little gaps in between. There's drill holes. All those need to be filled. And then it's communicating left and right because you have wires going from one side to the other. Yeah,
lateral movement.
So if there's a hole over here, it's doing it over here.
And people think to seal the outside, so it needs less penetrated there.
Correct.
Here, no one thinks to do anything about it.
So if we think about the process that's happening, when we have a hole even on an interior wall, and you're in a bathroom with a heated environment, more steam and vapor pressure is going to follow any pressure differential there is, which means now on your interior wall, you're actually attracting moisture into an interior wall, which is now building up in some location in that wall in contact with cellulose, which means it's a breeding factory. So the interior walls are as important for air sealing as the exterior walls.
That's interesting because we had thought about on certain bathrooms starting to almost make it a standard, like just wrap it in like a Seagull My Best or something.
I would actually, on a lot of bathrooms, I would use something like the what's the company? They make Schluter.
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 And actually using their membrane everywhere.
Schluter.
And just wet room the whole thing.
Right up to the ceiling.
You know, if you're already doing it in the shower.
Why stop here? If this is a bathroom that's only this much further, use the whole thing up to the ceiling. Now you've got your entire thing is basically a pan. There's never a potential for mold to happen behind. If you see pink in your bathroom, that means there's more behind. It's come from somewhere.
It doesn't start.
It doesn't start there.
No.
So but I thought that was pretty cool to see it in both spots.
I would not have expected that as much.
Remember always though, when you think about air movement, you have to think about moisture movement.
Vapor.
You have to look underneath the house, make sure there's no water pressure,
Mhm.
anything hydrologic coming up, any pooling of water. Because if you put a cap on a building, if you seal
Now
it
we've
up,
made a greenhouse.
you have created a greenhouse. So that's the next part of trying to avoid the issue.
But the nice thing is what we've done is we could easily go around chasing leaky outlets and leaky things, but by just putting a hat on it and capping the intake at the bottom, we've now made our largest impact, or probably the least amount of effort, as opposed to having to chase lots of little things. Now we can choose to chase little things, so we can have massive impact just based on those two things.